Okay, now I'm going to cover on tutorial 9 on correlation and regression. So this tutorial also uses SPSS to generate the tables and results. Okay, for the first, you have to download the bodyfat.sav file as well to use together with your SPSS to analyze the data, because the data analyzed is from that particular file, which is also uploaded in Spectrum. So once you have loaded it into SPSS, okay, then you can start doing for the first question. Find if there is any correlation between the following variables and make your conclusions based on that, right? So here you can see there are three, which is between weight in pounds and body mass index and fat-free weight, weight in pounds and height in inches. So let's do the first one, weight in pounds and body mass index. So here I have loaded the bodyfat.sav file. Okay. So you just have to go to analyze, go to correlate, and go to bivariate. So go to analyze, correlate, bivariate, and here, okay, I'll just reset again. So what you have to do is weight in pounds is one variable, and the second one is body mass index, right? So you choose body mass index, and you don't have to change any other things. You can just leave it as two tail, if you or you can change it to one tail. Here are the three different correlation coefficient types that you can choose from: Pearson, Kendall-Stau, or Spearman. You can actually try both and report both results as well. Okay, you can see how's the difference of the results when you use different correlation coefficient tests. So here I'm leaving as the default Pearson. I do not change anything in options. Okay, so once I press OK, then you can see here in the screen. So this is the correlation value here, which is showing 0.887, which is highly correlated. That means, as you know, the range is between -1 and 1.0. So as it goes towards 1.0, it is highly correlated. That means it's more to positively correlated, right? Of course, this will be 1 and 1 because this is the same variable, weight and weight. So definitely it's going to be 1 because it's exactly the same, right? Same with here, body mass index. If you see, it's 1, right? And if you click here, this value to see the significance, it's actually a very small value which is close to 0, right? So if you double click, or you can see here, it's 5.0229 dash 86, right? So it's a very small 0 value. And this result is significant at 99% confidence, right? That's why you see the correlation here, the asterisk here. That means this is positively correlated at significance level of 0.01, right? Which is quite high, and it's a significant one, right? So this is the first example. So you can do the similar analysis for the other two. So let's refresh. And then the other two is body mass index and fat-free weight. So if you can see body mass index and fat-free weight, okay. So this is 0.547. It is still correlated, right? Positively correlated, and it is significant because it's a very small 0 value. And the third one is weight in pounds and height in inches. So I remove fat-free and body mass index. We have weight in pounds and height in inches. Okay, so if you can see, it is also positively correlated, which is 0.487. Okay, and it is also significant, as you can see here, very small 0 value, which is less than 0.05, right? Or in this case, less than, yeah, you can use any default value. So the confidence level by default that we normally use is 0.05. Okay, so we are done with the first question. So the second question says that find the significant predictors for body mass index. Use only density, height, weight, and fat-free weight. Report all the necessary results. So from the question, what you can see is the predictors here is density, height, weight, and fat free. The one that we need to predict is body mass index, right? So how do you really match it with the um, y equals to um, the mx plus c, right? So here the predictor is the x value, which is density, height, weight, and fat free. Okay, the predicted value or the dependent value here will be variable will be body mass index, which is the y. Okay, the y value, which is body mass index. So you need to know this because when you are using a regression in SPSS, you have to know which is dependent variable and which is independent variable. So in this case, this is dependent, and the density, height, weight, and fat free are independent, and these are actually the predictors. Okay, so when you go to SPSS, let me close this first. You go to analyze, go to regression, and you go to linear, and you can see here there is one block here for dependent and another block here for independent. So in this case, for this question, the dependent value is the body mass index, right? Because that is the one that we want to predict. So body mass index goes under dependent, and the predictors will be the other variables, and those will be the independent values, which are the x values. Okay, so which is density goes under independent, height, weight, and fat-free weight. So I'm not going to change any other options here. Okay, and as you can see here, the r square value is here, right? To see how this is quite high actually, if you see the r square value, which says that at least 99% of the data which is observed here, which is plotted, actually fits the best fit line, right? And if you can see here the coefficient value, so refer to this coefficient table. Constant value is this constant value, which is shown in this column B here, 57.152 is the intersect value, right? The intersection value is 57.152. These three predictors, density, height in inches, and fat free, sorry, there's supposed to be 4. Okay, and hold on, yeah, I'll redo again because weight, sorry, regression, linear. Yeah, there's supposed to be density, height, weight, and fat-free weight. Okay, all right. There's supposed to be 4 predictors. So now we have 4 predictors here. So as you can see, this is intersection value, which is 79.665. Okay, this is the correct one, right? Constant, which is 79.665, is the intersection value. The slope value are these, which are linked with these predictors variable. So in this case, we have 4 predictors, and the slope value is negative 27, negative 0.716, 0.115, and 0.030. So these are the values which will be your x value. Okay, your predictors will be the x value. This will be your intersection value. Okay, so basically these predictors value are the slope values, and what this shows is here whether these predictors are significant or not. So usually only when it is significant, so in this case maybe less than 0.05, or if your confidence level is higher, say 0.01, then if it is less than 0.01, then you choose that to be included in your equation, in your regression equation. So in this case, all these 4 are significant because they're very small, close to 0 value, right? So they are all significant and can be included in the regression equation, which is for question number 3. Okay, because for question number 3, you're supposed to derive an equation for regression based on question number 2. So in this case, all 4 are significant, so all 4 has to be included in the regression equation. Okay, this will be your intersection value, this will be the x values. Okay, and we have to include all because they are all significant. So if you look at question number 3, it says write the regression formula for question 2. Okay, so I have prepared here, as you can see, for question 3, write the regression formula for question 2. Okay, it's basically is this, right? So y that you are going to predict here is the body mass index, okay, equals to the intersection value, which is 79.67. I got it from here, 79.67. And these are all the predictors. I included all 4 because they are all significant. If one of it is not significant, for example, just say it is its significance value is more than 0.05, then I would not include in this equation. So this W just I put it there to show you that it referring to which variable. Okay, for example, this refers to weight in pounds, this refers to height in inches, this refers to fat-free weight, and D here refers to density. So all the 4 predictors are significant, so we included here. So the equation is y equals to 79.67 plus this is the slope for that predictor. You can see I got the slope from here, 0.115 for weight in pounds. Okay, and if you see for fat-free weight is 0.030. So it is here 0.030. Okay, and you can see for density is negative 27.37. Negative 27.37. So I rounded it here. So it's 27.4 D. Right. So this is the equation, right, based on the results that we got. So moving on to question 4. Find the important predictors for body mass index and the rest of the circumferences variable. Sorry. Okay, here, this one. Find the important predictors for body mass index and the rest of the circumferences variable. So similar to what we did just now. This. So I go to analyze, regression, linear, I reset. So the predictors for body mass index, that means the dependent value, it is still body mass index, and rest of the circumferences. So let me see what are the circumferences we have. Okay, we have neck. I can highlight together neck, chest, abdominal, hip, thigh, knee, ankle, bicep, forearm, and wrist. These are the only circumferences that I have here in this list. So I add everything, press OK. So as you can see, the circumference, these are all the circumferences variable as the predictors, which is the x value, and this is the slope. So as you can see, not all are significant. There are some which are more than 0.05. So the ones which are significant is only chest circumference, abdominal circumference, hip circumference, thigh circumference, knee circumference. The others are not significant, so I will not include in my regression equation in question number 5. Okay, so if you can see, there's 1, 2, 3, 4, 5. Only 5 variables will be chosen because they will be the best predictors for this body mass index. Okay, because the others are not significant, so we are not going to include that in our equation because they are not good predictors. So what I will do here, I have done for the second one. So this is the value for the intersection, which I got it from here, negative 12.856. I put it here. Okay, this value. And then plus, so I have 1, 2, 3, 4, 5. As what I mentioned just now, there's only 5 which are significant. Chest, abdominal, hip, thigh, and knee. Chest, abdominal, hip, thigh, and knee. And these are all the slope values that I took from the SPSS. Exactly the same method. Okay, so this is the equation for predicting body mass index because these are the only good predictors found from the regression analysis that we did in SPSS. Okay, so basically that answers the question 5 as well, right? Write the regression formula for question 4. So similarly, you can do this for your group project as well, right? You can see which variable you can predict using some other variables. But before you are putting them in a regression equation, you have to decide or determine whether they are significant and whether they are good predictors or not. If they are significant, usually they are the good predictors. So those variables you can include in your equation. Okay, so I think that's all for this tutorial. Okay, yeah, any questions we can discuss during the live session. Thank you.